Hi, this is Supreet, and today we're going to talk about something very interesting topic, which is the Prime Video going back to monolithic architecture from microservices. So we always see people moving from monolith to microservices because it has some advantage. Creating different services makes applications more scalable. Is it is easier to maintain, and then it is easier to manage the services as well. Right. But then Prime Video has reverted back their microservice architecture to monolithics in a specific use case. Now let's gonna see what is that use case. Now here is an article which they have published. So basically, they have a Prime Video monitoring tool, wherein they are going to collect the information about the videos being watched by the users, and then they are going to detect the quality issues, for example, corruption issues, audio visual sync issues, and so on and so forth. Now, this was a microservice architecture earlier. Now they wanted to revert back to monolithics for some reasons, where they wanted to ensure the cost that they have incurred is not elevating, or it is not shooting up. Now they say they had some bottlenecks. They also noticed some scaling issues, um, which prevented them from monitoring thousands of streams. Uh, so they had to revert back. Now, I'm going to show you that architecture, but on a high level, they used AWS step functions, they used Amazon Elastic containers, and then they used compute services, so on and so forth. To create those architecture. So now if you look at the architecture, you're gonna see there is a customer over here who is going to watch the audio video streams, and they had a media conversion service which used to collect the information and dump it into the S3 bucket. So these were basically audio video buffers, and the other metadata that used to be dumped into S3 service. Now they had Amazon step functions, which used to have AWS Lambda, uh, which was having an orchestration logic to create detectors. What are those detectors? These are defect detectors. Now there were multiple defect detectors created, which used to connect to Amazon S3 bucket, gather those information, collect those information from S3 bucket, and then analyze those issues, categorize those issues. And then there was AWS Lambda as well, which used to aggregate those results, and then those aggregate results were again dumped into a separate Amazon S3 bucket. And then there were notifications being sent via Amazon SNS service at the real time, of course. So this was the initial architecture. Now, as they say, they had scalability issues, they had cost issues because they were using step functions, creating detectors, using S3, a lot of things, right? So they had cost issues as well. Now, in the new uh, architecture where they reverted back to monolithics, there were some changes being made. Um, so they say the second cost problem we discovered was about the way we were passing video frames around different components. Um, so they say they built microservices that splits video into frames and temporarily uploaded images to S3 services. So using Amazon S3 services for all this purpose was resulting in higher cost as well. This was one of the component which was shooting up the expenses. Now, moving to monolith architecture, this is a new architecture they have implemented. So, wherein everything is being incorporated in Amazon ECS task. So this is the container services service that Amazon provides, Amazon ECS. Now they have created a ECS task which contains all the orchestration logic, wherein the customer watches the video, and all that video that is being viewed is being passed to media converter. Now there is an orchestration uh, logic or a service which is inside the ECS task as well. So media converter start conversion of the audio video stream that user has watched, and the result is passed to instance memory. If you see here, now the usage of one of the S3 bucket has been reduced or eliminated. Instead they are storing it in instance memory. So that part of the cost reduction is reduced. Cost expense has been reduced. Now from the instance memory they also have detectors, issue detectors, which is also inside ECS service. Now that data from the instance memory is being passed to detectors, and they also have aggregation logic inside the ECS task as well. So over here, the results is been aggregated, and it is finally passed to only one of the Amazon S3 bucket. As well as now, they also have SNS service for notification as before. But then this is the new monolithic architecture, wherein they have dumped everything inside ECS task. So conceptually, the high level concept remains the same. They have media converters, they have detectors, they have aggregation logic, and then they have notification service. But here they have dumped everything in one ECS task. Okay, so there are some changes that they have made. um, and they say they are now able to reuse a lot of code and quickly migrate to new architectures, right? So these were some of the changes that they have made. Yeah, at the high level, uh, this is something that they have done, right? So now results and takeaways. So they say moving our service to a monolith reduced our infrastructure cost by 90%. Now this is a huge takeaways, huge advantage. Now reducing the cost by 90% is an amazing reduction and an achievement. So they also say they reduced Amazon EEC to computing um, cost further, and now it's more easy to scale as well. So let me know what advantages did you observe more, so that we can all learn that it is not always uh, just moving from monolith to microservice architecture, but we will have to understand what is our use case, what is the benefit in moving from monolith to microservice architecture in our use case, and then make a brainstorming have a brainstorming session around it, and then move instead of just for the heck of converting from monolith to microservice architecture. So this is a great lesson. So yeah, this is about it. Thank you.